All right, let's talk about percent composition. We're going to examine percent composition in the context of the percent composition of bubblegum that is sugar. Wow, Yoda speak like I do. Why don't you write down Yoda since I'm having trouble speaking? Go ahead and write down Yoda. I hope everybody's writing down Yoda. One thing that we want to talk about before I get too far into things is an important part of the experiment that you kind of need to understand. It's what happens in your mouth. Now, you all are probably aware of the fact that at this point in your life, you have saliva in your mouth. And saliva plays an important role in the digestive process. Saliva begins the breakdown of sugars. So when you place something in your mouth, the saliva in your mouth starts to digest the sugars. So when you place a piece of gum in your mouth, the saliva is going to remove all the sugar from that piece of gum. If you place a piece of candy in your mouth, why do you think that piece of candy disappears? Perfect. It's Christmas time, and you've gotten one of those peppermints because you're visiting your grandparent and they always have that hard candy laying around the house. Well, you put that candy in your mouth, and that candy is nearly 100% sugar, with a little bit of flavoring. Sugar, sugar, do 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 do. Oh, honey, honey. Wow, the Archies that sang that were a long way from the Archies that appear on Riverdale, huh? Ooh, it would be really cool if they worked somehow into Riverdale, them playing a cover of that song, just to cycle back to the old 60s cartoon show of the Archies. But I really am digressing there. That peppermint you place in your mouth is nearly all sugar. And what happens to the peppermint in your mouth? It goes away after a while. You suck on it, you feel all that saliva running through your mouth, and the peppermint disappears. Why? Because that saliva digests and dissolves the sugar. So whatever you put in your mouth, your saliva is going to remove the sugar from it. So that's an important concept to understand in this lab. Your mouth is going to dissolve sugars and starches, start the starch digestion process as well, but it's going to remove all the sugars that you put in it. Now, let's look at some additional definitions that we have to talk about before we get to the labby part of it. Did I just say labby? Ugh. At any rate, let's move on. What is percent? Percent in chemistry is no different than percent in any other part of your life. Percent is part over whole times 100. In chemistry, there's an entire field of chemistry known as analytical chemistry. It is the best, most exciting field of all of chemistry, and it's the field of chemistry that all the smart and really cool chemists go into. I say totally unbiasedly. Analytical chemistry is the field of study of Analytical chemistry is the field of chemistry that determines the composition and identity of an unknown substance. It can also be thought of as the field of chemistry concerned with measurement. Analytical chemists are the chemists that devote themselves to the study of measurement. They're also the field of chemistry that's so popular and so cool that they're constantly making TV shows about them. That's right, if you've watched CSI, NCIS, forensic chemistry is a subspecialty of analytical chemistry. Analytical chemists are the chemists that you would give an unknown substance to, pay them thousands of dollars, give them a couple months, and they'd come back and tell you what the substance was, and what the substance was, and what its concentrations of the components were. Analytical chemists are one of the really good, one of the really easy fields of chemistry to find work in. All factories generally employ at least one analytical chemist as part of their QC process, their quality control process. Also, if the factory itself or the production facility itself doesn't directly employ a chemist, they employ a subcontractor who employs a chemist to certify that they're meeting EPA regulations, environmental protection regulations. So analytical chemists are also the chemists out there that are measuring your air to make sure it's safe to breathe and measuring your water to make sure it's clean. Another thing they do is when you buy food and you're reading the calories on the back and the percent composition on the back, they're the chemists that determine that. So not only do they help determine what's on the back of food labels, but they are also helpful in determining how some things are sold. For example, I have a background in coal chemistry. When somebody buys coal, they just don't say, hey, give me a pile of black shiny rocks. They actually say, I want to buy coal that's a certain percent carbon, a certain percent hydrogen, a certain percent oxygen, and they're generally also very concerned with the percentage of sulfur and the percentage of chlorine and the percentage of nitrogen for environmental reasons. They buy the coal based on its percent composition. What you're going to be doing in today's lab is you're going to be determining the percent composition of a couple sticks of gum. Let's take a look at what you're going to be doing. Let's say you have a stick of gum here. All right, you take the mass of that gum, and that gum weighs 2 grams. You put that gum in your mouth, and what do you think happens to that gum in your mouth? Well, as you chew that gum, it gets surrounded by saliva. The saliva in your mouth will dissolve all the sugar in the gum. So what happens is the sugar leaves the gum and you're left with a very wet piece of gum. You take the piece of that gum, you dry it off best you can, and you take its mass again, and this time your stick of gum weighs 0.8 grams. What happened to the missing mass? What happened to the missing mass? It dissolved in your mouth. In other words, the missing mass is sugar. So to get the amount of sugar, you're going to take, I needed a clean slate here, we've got gum, 2 grams, we had the gum all chewed up, all chewed up at 8 grams, oops, not 8 grams, .80 grams. That's your ABC gum. Already been chewed gum. Oh, come on. Don't tell me. You may deny it, but I guarantee you made that joke when you were in 2nd grade. Alright. You obviously just weren't hanging with a cruel crowd if you did. Alright. So we have our gum. We have the gum after it's been chewed. And that's going to equal the mass of sugar. So 2 grams minus 0.80 grams equals 1.20 grams of sugar. So in our initial piece of gum, we had 1.2 grams of sugar. So what's the percent sugar going to be? It's going to be equal to the mass of sugar, our part, divided by, here, let me be very specific with that. Let me try this. The unchewed gum times 100. So our mass of sugar in this case, our percent sugar would be .2 grams divided by 2 grams times 100, or 60%. And I'm just going to check myself before I wreck myself real quickly here. Alright, let's see how you handle an example right after you write down the word grievous. Write down the word grievous. G-R-I-E-V-O-S. Write down the word grievous. Alright, so you've chewed a whole lot of gum. Matter of fact, you started out with 8 grams of unchewed gum. You chewed it, and after you chewed it, the gum, you dried the gum, and you got a mass of 4.8 grams. So what was the percent sugar of your gum? Pause me and try working it out. Come on, pause me, play along. I know, you've got all sorts of things to do, and you're anxious just to get through this bloody lecture to see if I say another key word, and start the experiment, and I'm wanting you to pause. Did you pause? I hoped you paused. Alright, whatever. Let's take a look now. To get our quantity of sugar, we subtract the 2 because the sugar disappeared into our mouth. And 8 minus 4.8 equals 3.20 grams. So that's our amount of sugar. So .20 grams of sugar divided by 8 grams of our initial gum times 100 equals 3.2 divided by 8 times 100 equals 40%. Notice that our percent sugar for this gum is different than the percent sugar in the last example. Is there anything we can conclude from that? Yeah! We conclude we must be dealing with a different brand of gum. If it had been the same brand of gum, then no matter what pieces we put in there or how much gum we put in our mouth, the percent sugar would be the same. But because we're dealing with a different brand of gum, our percent sugar is different. Or vice versa, because our percent sugar is different, we know we must be dealing with a different brand of gum. Often on the news, you'll hear people talking about ppm, or parts per 1 million. Parts per million, or ppm, are just really small percentages. To get parts per million, you do the exact same thing you would for a percentage. You would do the part you're interested in divided by the whole, but instead of multiplying for 100 like you would for a percent, you're going to multiply by 1 million. Previous example. We'd already decided in our previous example that our amount of sugar was 8 minus 4.8 was 3.20 grams. This time, instead of asking what percent sugar, let's ask what is the parts per million of sugar in gum. The problem is going to be worked the exact same way, except you're going to take 3.20 grams divided by the 8 gram. You're taking that same part that we did last time over our whole, but this time we're going to be multiplying by not 100 but 1,000,000. And I'm sorry, I used scientific notation without thinking about it last time when I wrote that 10 to the 6th. you can just type 1,000,000 into your calculator that way. And you do that, so you get 3.2 divided by 8 times 1,000,000, so you got to type in 6 zeros. And you get, as an answer, 400,000 parts per million of sugar. So parts per million really isn't any different than a percent. And hopefully this will make you feel a little bit better. When you hear food packages or on the news them talking about parts per million, you now know what they are. Chemistry is easy, life is hard.